Okay, hi everyone. Another live stream. Different topic. This is a review of geo functionality and related things for version 13 of Autumn Language. Actually, I think we've got some other things to look at here first. Oh gosh, the time system option. Okay, let's take a look at some of these.
Yes. So I suggest we start with geo, and then we look at time and dates and time.
Okay. Oh, look at this. This is exciting. We've got Astro position. I'm thrilled.
Yes,
Okay.
but I'm afraid I'm not ready for that today. So we have a lot of material with geo and dates. So let's leave Astro for.
Fine. All right. New default geo range.
Yes. So this is something you requested. It's the fact that when there is an error, you get a map of Champagne, say, and you wanted a map of the world. So we have changed that.
Good. Okay. Fine.
So notice that if you still, you still get the same map if you ask for geographics of here, right? So if you specifically ask for a location here or Paris or whatever, you get that map. But if geographics doesn't have information about a location, it defaults to a world rather than.
The thing I'm most interested in is the vector geographics.
Yes, that is at the end. So let's go quickly through these other small things, and then we go to that.
It is going to work, isn't it?
We believe it's going to work. It's still slower than we would like it to be. But I mean, it happened with the other geographics that it took several iterations to get the speed right.
Mm-hmm. I wonder whether there's a way of having it come in, whether there's some kind of way. Maybe it's of having some kind of asynchronous, refinement.
We have tried several things, and we even have the tiles in the CDN, but still, it's slower than we would like it to be. And there are, I think it's worth to wait for the gain in quality that there is in the maps.
Yeah.
But we have some intermediate suggestions. You will see.
All right. Okay. All right. Let's get that was skipping too far ahead.
Right.
Okay. Multi-position spec for geovisible region.
Yeah. So that's another thing you had suggested, that geovisible region takes a list of positions and you just get a list of the corresponding geovisible.
Seems fine to me. Okay. Yeah. Support for epilogue.
Yes. So this is something that actually Christopher's requested. And now we can have geoprimitives in epilogue too, and they will be properly understood. The important thing that, and here we follow what epilogue does in graphics, is that whatever you put there is not taken into account in the georange estimation.
Okay, that's interesting, but good.
Yeah, it is exactly what epilogue does in graphics.
Okay.
Okay, so this is something that will be important in a moment. And we have this new geo background, which is just the labels of the vector maps.
Okay.
Just the labels. And so in the next one, you see that we can have a list of geo backgrounds, and they will be kind of overlaid. So for example, in the first one, we have the street map with no labels, and then we put on top the vector labels.
Yes.
And so this is a nice combination that we can use. Oh, goodness. This is a problem from entity value, actually. Yes, we are seeing this recently. But it's fixed. Tony has fixed this. So this is a case in which you see with a single geo background, we can change the properties of one or the other. So we are having there two different versions of satellite. It's one with a different opacity and a different geo server.
Okay.
So this is just another example of how with a list of geo backgrounds, we can do rather flexible things.
Wait a minute, what? I don't, oh, I see. These are literally, they are graphically ordered, so to speak.
Exactly, as you place them.
Okay.
So the last one will win. Or for example, this is another thing in which we can have the maps with a given zoom on the bottom, and then the labels with a different zoom on the top, so that you can control. This is something that the users had requested multiple times, that they want very detailed backgrounds, but not so many labels.
Yeah, that's nice. That's nice. Maybe there should be another way to control that, a higher level option to control the labeling density. By the way, given that we're talking about this stuff, maybe somebody should see if Christopher happens to be available.
Okay.
Determine that.
Yeah, we'll check.
Okay. In other words, I could imagine geo-label density or something as an option. That would be a bank switching option.
Perhaps.
I mean, I would think that a label density will be relevant for other things too, although, well, maybe not. This is really a case, the geo case is really a special case of this.
Mm-hmm.
Yeah, I think so, but there are other things that is worth thinking about for labels is what type of labels. This is where you've seen Apple Maps and Google Maps innovate. Is it just transportation, which it started with, or is it points of interest and discovery, for instance?
I hardly call that innovation. That's been on maps for millions of years. No. But anyway.
Read a detailed review of it. You'll see the difference. I mean, is it just subway stations and roads? Or is it like buildings and parks?
No, I know. I've seen a lot of that stuff.
They have different priorities.
Yes.
Okay, in any case.
About the density, something that we, so the styles already come with different densities for each type of label. So maybe what we could have is a factor that we could apply to these densities, so to make them more sparse or not, for example. That could be possible.
But I mean, the basic point is, go ahead.
No, that we are already applying some kind of density for each layer of labels. So it will be
I mean, so in this case, for example, if I said vector label zoom level 4, wow, why is that so slow?
Yeah.
Well, it's hardly an impressive additional number of labels. I mean, if I say zoom level,
right, because
7,
the density won't change. What will change is the layers it chooses to put.
That's going to download a ton of data. It has to download zoom 7 for that region.
But I don't understand what happened here. Why are the labels so big? This seems wrong.
The size, it is the size is the appropriate for the map you are seeing. And we have many more labels, but the collision algorithm is avoiding collisions. So that's why you are not seeing tons and tons of them.
No, why? I don't understand why. Is this on this scale of map? Mm-hmm. These are the labels because the zoom level. I'm so confused. I'm sorry. For Italy, there is a natural zoom level which will cover all of Italy, right?
Right.
And what I'm doing is I'm faking that with respect to the zoom level for the labels. But why are the labels so big? Why did the labels get bigger between this case here of zoom level 3 and zoom level 7? Why did the labels ever get bigger?
I mean, the fact that they are similar in size is what we expect. The fact that they are slightly bigger,
it's more than slightly. Look, it's a factor of 2 bigger, at least. Look at that tiny San Marino there.
No, right, because you are zooming in, so that expects a much larger map, let's say. So that's why the font is a bit larger for example, for country names.
It's not more than a bit larger. Look, 4 zoom levels. Look at how much bigger it is. It's like a factor of I mean, at least 2 for an area.
Yeah, so I think we are taking this, perhaps the size, the zoom from the wrong place here or something like that.
I think so.
Mm-hmm. Yeah, we'll look at it. Yes, it's true that we expected more, not colliding still, but yes.
Can you try geographics of like Rome with geo zoom level goes to 7? And I don't remember if that input had a back of what it said for geo background.
Yes,
Okay.
so you need to set that your background goes to, say, vector classic.
Why isn't it in the autocomplete?
It is.
No, but it should be. I mean, look, we should.
We'll reorder it to the top, but
Oh gosh, this is so slow, but very beautiful. See, there are many purposes for which you don't care about. I mean, it's almost like performance goal arrow quality type thing.
Mm-hmm.
Because that's very beautiful.
Yep.
and how does the font size compare in that one with the one where it was really big?
Look at that. Look at that magnificent rendering. Just the question is, why is it so comparatively? So if I were to look at this, this is a bunch of graphics promoters, is that right?
Mm-hmm.
Is it at least compressed and so on?
I don't think
yes.
so. Compressing with sense.
The representation in the front end is compressed.
Oh, I see. But the input form has the standard primitives.
The input form of this doesn't have compressed data. So if I were to say string length, well, why? Look, it's even, look, the front end is even, look at that. What the heck's going on there? See, it's even spinning when I just mouse into that region. Something is very wrong here.
We
See,
can't see your cursor spinning if that's what you're
okay,
saying.
well, it spin, okay. Spin. No, it stops.
Just from you clicking on the image.
Just from clicking on the image. And I've seen that in some other stuff in 13. I think, look, just clicking away from the image, it spins.
Are you in prototype right now?
No.
Okay.
Six megabytes of crud there. So is it in fact a compressed string? It certainly should be, shouldn't it? The input form should just say compressed graphics, should it not?
No.
Why not?
Compressed graphics is, a notebook representation, a serialization representation. If it was compressed graphics, then we wouldn't be able to actually do things on it.
Okay.
Right. We can edit things and replace styles.
Well, that's lovely, but most people don't want to edit the maps. We don't care about that. What we care about is that these maps render fast and not 5 times too slowly. Right? We don't care about editing the graphics. We profoundly don't care about that. So what can we do if we ignore editing graphics? Can we make it faster?
All right, I just joined, but are you talking about, would this also affect, like, if you asked for, part 1, or is this just affecting like the interactive editing? By part 1, I mean, like, if you dig into the expression that is a geographics object.
I'm not sure because we didn't know what we're talking about yet. I'm really wondering why there's so many freeways that just end in Italy, but we probably don't have the right group of people here to answer that.
I don't think they end. I think they like change into smaller classes of roads that get rendered differently.
Or go into towns that aren't being shown right now, or.
Well, you can see like some of them. I've had this. I've seen this before as well. Like if you zoom in, like for example, if you look at I can't pronounce this, Frosinone or something like that, you can see that the big roads turn into smaller roads. But
Also, why is Frosinone got a bitmap there? Why does Rome have a big bitmap in its center?
Francisco, so I think
yes, because we are still using bitmaps for these signs for these markers.
What kind of markers?
For the city markers and for the
Why?
shields.
Why? I mean, everything else is beautiful. Why do we have I mean, how many markers are there that we have to replace with vector?
Basically, the city markers and the shields.
Okay, so we should
Because
fix
they are,
that, right?
Well, the original format was SVG, but we cannot support SVG for importing. So yep. That's why we were using the sprites in
what?
In bitmap.
Well, we shouldn't use bitmaps. We shouldn't use bitmaps. If necessary, we should change the graphics. Am I making sense? So, we can take the SVG, import whatever we can. If there's some weird element that we can't import, then we have to worry about that. And then somebody can just create that piece of graphics for us. Does that make sense?
Yep.
Francisco, does that make sense?
Okay. Yes.
Okay.
Yes.
Is there anything else that's left as a bitmap?
No, that was the only thing left.
Okay, fine. Let's fix it. Not get blocked because a piece of SVG can't be imported. Okay. Okay, now I want to ask the question, how can we make this faster? We don't care about editing. Am I making sense?
Yep. So there are always two parts, and the examples further down on speed were showing that. There is first the download of data, which is the main bottleneck. And then when you iterate the map and everything is cached, these vector maps are still a few times slower than the old maps. But
okay, where is that speed? Where is that? Is that in the rendering or is that in something else?
It's in the processing of all the data, placing all the styling things in front, and then
okay. Let's be very specific. Okay, so let's take this example as a bitmap. Okay. So here, let's get rid of this. That just came up instantly, but that may have been because it was cached.
Probably. Can you open the speed section and then you have clean or fresh examples there? So that's trying to show the first time versus the next time, and then again with vector geographics.
Okay, so that's 5 times slower.
Right. And
is that the typical factor?
I think so. And you see how the repeated timing, once all the vector stuff is cached, so now it takes less than 1/10 of a second, but
it's still 5 times slower. Well,
exactly.
That's actually 3 times slower there.
Yeah. So that's a typical thing we see.
Okay. Okay, but so just to understand, and I mean, how much bigger in terms of notebook size is this?
In regions like this, it's similar. In very, very populated regions, I mean, big cities, the vector maps are bigger because they have tons of street built-in information.
Okay. There's a comment from Sander on our live stream suggesting we try a little experiment here.
That is a bug. It's fixed. There's a pull request for it. There's no need to do the experiment.
What is the bug?
The raw geoposition case is much slower than the point of geoposition case.
Okay. Okay, I understand. Okay, fine. Okay. Okay, so let's come back over here. All right, so let's understand what is taking time in this flow. Let's consider the case, first of all, where we're downloading data. So the experiment I was about to do was just to ask the question, if we do a 2-string string length of this thing, when, okay, so there we've got this. Let's just do this again. That's lovely and fast. Okay, so we've got a difference in size here.
Some of that might not, I mean, that doesn't necessarily mean it was more to send though, because if it, if it has to write, the symbol style 500 times, then that doesn't, that's not
right. I understand, but this difference,
But
that's a
how
factor
is
of
it?
3.
I can't remember now. How is it sent? Is it sent as key value or is it sent as boxes? Does it, Jose or Francisco?
What are you asking about?
The
old
size
data?
in the notebook is the box size, right? It's not the input form size.
No, I think it's the input form size. Now you can
Well,
make 2 boxes.
I mean, the boxes, should be
No.
pretty close to the input form.
You think? But
Yes.
that can use compression, but the input form can't.
Correct.
Let's say byte count. Let's just see what that is. Byte count of %5.
What is that? The standard form, probably.
No, that's just the byte count of the in-memory.
No, but count the memory.
Right. And now this one, 9, is going to be much smaller, I predict. Yeah, that's a big factor. That's because that's just a compressed image. Right. By the
Yeah,
time it
why
got
is that-
stringified, it was in hex or something. Go ahead.
Why is well, okay, I guess I think something must be getting removed in the input form in the first case, because the string length of the input form is less than the byte count.
Huh. That's very odd.
I mean, I guess there could be non-ASCII stuff, but I bet it's that the input form is getting rid of some stuff.
Shouldn't be. And
It's
generally
possible that
speaking.
the expert representation takes some additional space.
Maybe that's it then. I mean, if it just has a ton of just symbolic stuff. Yeah, I guess that's true, because if an expert is like at least 64 bytes or something, I mean, or 64 bits, and you could have just a couple bytes in a string that might be shorter.
What the heck is all that? This is just completely uncompressed stuff.
Right.
So what got sent over the wire here?
So the data came in this, how is it called, Francisco? What we read with protobuf?
PBF. Yes, the protocol buffer. So it's compressed. The data is compressed in a very efficient format.
How much is it compressed?
Well, we have the whole world for all the zoom levels in 44 gigabytes. So
That's
a good
quite
factor, because
compressed.
when we expanded, everything was, yes.
How big was it when expanded?
It was kind of almost a terabyte, I think, when we had all the database done.
Okay, so that's a factor of 1,000 divided by 40. So that's a factor of like 20. Right. This is where it absolutely gets pathetic, isn't it? 25, yeah. Okay. It's kind of an interesting statement on our civilization that we're 44 gigabytes of mapping data. I wonder how much of that is forests and things, and how much of that is human created. Okay, never mind that. Okay. So we think there might be a compression of a factor of 25 in the transmission. Again, somebody must have profiled this. What takes time? In the vector map case, what takes time? Don't say everything. Just go through what are the stages and how much time do they take? What takes what percentage of the time?
Let's see. So the first time that we have a map, we have to do some pre-processing of styles. We cache that, and this lasts for how long, Francisco? A week or something like that, just in case we make changes. And then in the first...
Right, the cache is a week. Yeah.
A week, yes. So then we have to download the data.
So wait.
Yeah.
That's a pre-processing. So we're talking vector maps here.
Yes.
Correct? And you're saying there's a pre-processing of the vector map.
Of the style. So the style has some pre-processing that we have cached, but it has to be done from time to time. And then we download the data. Sorry. We download the data, and then it's the fact that we download geometric data without the styling, and we have to put together the styling information with the data information. That also takes some time, not as much as downloading, but it's probably
okay, so let's walk through this again. Okay, so hold on a second. So first of all, there's pre-processing on the vector data that is done on the server side, which we do automatically down to some zoom level, presumably, but only, I mean, why don't we just know which tiles people have ever requested? And why don't we just basically do pre-processing for all of those tiles?
No. First, Jose first was talking about the styles. So the first thing we pre-process is the style information. So let's say Italy is gray, Rome is black, etc. Right, and that takes a few seconds, downloading, processing that, and that's something that we cache because that we only have 8 styles, so we can cache them for a week. So
I'm sorry, styles of what? Are we talking about the style for every tile on the map, or are we talking about one central set of styles?
Something like Vector Classic is a style.
Okay, what is in the style? So is it just how to render a level 1 freeway, a level 2 freeway, a forest, this, that, and the other? What are you talking about? What's in the styles?
Yes, it's exactly that.
Yes, so exactly that. Italy uses gray, Rome uses black, highways uses orange, etc.
Okay, fine. How many different categories? So there might be 100 things, 100 different kinds of things for which we have to define the style.
241, yes.
241, okay, a decent estimate on my part. Okay.
Yes.
All right. Okay.
And then that takes some time.
Why?
And that's something
Why?
that
241 things is not very many. What are we doing there? We're saying it's this kind of orange and so on.
Is that just the download time that it has to do once a week, but there's no actual, is it actually computing something or is it just downloading something?
No, right. It has to compute the JSON file to convert that to the format of so to interpret the JSON file, basically the importing of the file and interpreting each.
That just sounds completely crazy. That takes more than about, a tiny fraction of a second. 241 things, 241 colors. How can that take more than just like microseconds? I'm confused.
I started listing things in order, and this is the first step, but it's a minor step. So perhaps we can. But
let's find out how long it takes, because it should take well under 1/10 of a second from what you described that it's doing.
It's also importing the images, the bitmap images.
No. Why are there bitmap images? You told me. Hold on. What is this step? I thought you told me it is the definition of styles. It has nothing to do with bitmap images. Is it styles or is it styling of images?
No. For example, these icons are part of the style also. So it's important.
Okay, but there won't be any more icons like that. Everything is going to be vector graphics. Okay, fine. Right. All right. So you're caching the styling information. All right, fine. 241 items. Each one is a little expression that represents certain styling. Is that correct?
Okay, Stephen.
And all the rules that involve. Yeah.
What about rules? What rules? What do you mean rules?
No, all the rules of the style, like for example, the color, the size,
Okay,
the
fine.
fact that it has some size at some zoom, a different size at another zoom, etc. So,
I
so it's
see.
not
Okay,
as
that could get
only
tricky.
200.
Yeah, okay.
Right. So it's almost a multiplication because you have 14 different zoom levels for 240.
Okay, all right. Now you're it's
different
making more
layers.
sense.
So, yeah.
Okay, all right, I get it. So that's the first thing that's done. Next.
So I sent you a command which will activate timing debugging. So it will be easier to discuss that. So evaluate what I sent in chat and then do a map.
Okay, so let's try this map here.
So this is cumulative. What you see at the end of indentation is accumulated, right?
Okay, let me try the same thing with a vector in the vector case.
Yep.
By the way, it would be nice if that was computable data that it returns.
The report?
Yeah.
That's a good idea. Mm-hmm.
Did you see it didn't scroll properly? Did you get what I'm saying? It didn't scroll properly. I've seen this with the version 13 front end recently. Look at that. When I click on the map, okay, it's spinning. Did you get what I'm saying?
Yeah, I'll pass this part of the recording to the front end team.
It's just wrong, really wrong. Okay, so let's
I wonder
go
if that's
back
related
up
to the thing that you reported earlier to John that you were typing after large
No,
stuff.
I don't think so. That's an old problem.
Okay.
That's an old problem. This is a new problem. This is a new problem that just rendering things is super slow. Okay, let's look here. So this is the previous version. Okay, parsing options. Okay, that takes no time. Geo-evaluate, that takes no time. Okay, let's see. So this is cumulative times, right?
Yes. So focus first on the numbers on the left, and then.
Okay, but the place where it starts getting big. So this is all, fractions of milliseconds.
Right. So this is a case that you had cached already. So that's why.
Oh, I see what you're saying. Okay, so geo.
So change Rome to some other place.
Yeah, I will. Okay, hold on. Okay, so let's just look at this. So then, I don't understand. If it's cumulative, how could it be 0005 at the end for handling? I don't understand.
No, it's cumulative with respect to the indented things that you see before. So for example, in section 5, you see these various things that are indented.
I see. So this is 9. Okay, so this 9B, 9C. Okay, so here that takes no time. It's a bitmap.
Right.
Okay.
So we have indented those cases which we usually see is lower. So we want to refine the information there.
Okay, so the big thing here is this one here, road shield motorway, blah, 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 collisions time. That was the big time sink in this case.
Right, because probably there are hundreds or thousands of those roads and we have to worry about them.
But why?
So what's it doing there though? I mean, that's not the front end rendering time. Like what processing is it doing there?
Each one comes with a name and we have to process the collision algorithm and we have to process the labels. We want to curve the labels adapted to the streets.
Okay, but there's a problem here. There are no road labels. Look at well, there are a few. There are A1 and A12. There are 3 road labels. So in all that time of 0.12 seconds, the only thing it managed to do was to determine the positions of 3 labels.
Yes, but it's difficult in advance to know whether they're going to succeed or not.
I understand, but essentially all of them fail, which suggests that there might be a better heuristic. And by the way, notice that in the bitmap, none of those labels make it at all. Am I making sense?
Yes, so that was processed with a different program. And
well, so wait a minute. This okay.
so the raster tiles were produced.
By the way, I don't think we should have road labels like this by default on our maps. I just think unless you're really doing street, well, it depends what level. I mean, at this level, when you're zoomed out this far, it seems surprising that we want those. Anyway, it's a different issue. Let's look at the corresponding thing with a place we didn't know about already.
Yep.
Let's try something like Manchester. I don't know why I'm picking that, but I'm figuring nobody actually asked for that. By the way, I noticed there's a bug with, okay, downloading geotiles.
Right. So you see that this is the main section now.
Okay, why is this not scrolling? It's not scrolling. Look at this. It's frozen. This is exactly what I've seen with tons of other stuff recently with version 13. Okay, there is a bug.
Okay.
Okay, so getting tiles, 8 seconds. What's all this stuff here? Attaching directives. Well, so getting tiles was 8 seconds. So right there we have our main, issue. So now let's look at the corresponding thing over here. That was just blindingly fast. Wait a minute, what happened here? Oh, wow, it got to Manchester and Massachusetts.
That's not the one you intended?
I don't know why I was thinking the one in the UK. But anyway, never mind that.
I got the UK.
Well, that's because it's a different heuristic base. I'm surprised it has any idea what my geolocation is. Okay, why is this? Okay, first of all, this map has much better labeling than this one. Oh, it's a zoom level 7. Well, who knows what it was. Something is very weird here. Look at the size of these labels. They're just wrong. Is that a consequence of the zoom level?
The size of the texts?
Yeah.
No, in general, the new vector maps have bigger labels because it increases readability. So Vector Classic may have a slightly too big or too bold.
Okay. But there's a problem there. But by the way, I'm noticing a comment on the live stream. There should be a way to switch off the stupid street names, which I agree with. We don't want street names. That's a different kind of map than, sort of our most common kind of map. Am I making sense?
I mean, really, there's probably a bigger project which is sort of specifying which layers you want. But
right, but look at this. This doesn't have the stupid street names. This one does. We should lose them by default at this zoom level. Look, maybe I'm being unfair because I picked a zoom level. Okay, but this was just blindingly fast. Do you think that's because we already cached it or something, or what?
No, we have improved a lot over the years, the download of these raster tiles. And of course, everything is prepared in raster image already. While here,
GeoImage download time 0.7 seconds. Okay.
Right.
Whereas here, where is it?
So it was like 7 seconds here.
Is that just because it's downloading 10 times as much data, or is it in some sort of processing thing?
Well, I think the processing is separate.
The processing is separate. Yeah.
Okay,
Right,
so let's understand the
download
protobuf data here. We think the protobuf is factor of 25 compressed. How big is the data here? We can presumably determine that by simply asking here in line 20, oh God, this is crazy. Look at this. This is spinning again. It's still spinning just from clicking there. I think there's some kind of memory leak. Look at this. I can't use this notebook now.
I'm taking timestamps every time this happens.
$12 megabytes. Okay, so assume that that's in the protobuf thing is factor 25.
Well, hold on though. I mean, how much, like, does the PBF file, like, does it have a bunch of other junk in it? Like, is this refined down to 12 megabytes?
We download more things. So in vector maps, we, together with the tiles needed, we download the area too, so that if you move a bit to the side, you already have those tiles. It also decreases the number of tiles because we place them in the CDN and we had some limits of number of files there. So we download tiles in groups.
Sorry, that was for the bitmap case or for the vector case?
The vector case. I mean, I think we do it also with the image, with the raster tiles, but not as aggressively as we do it with the vector. Do you remember the numbers, Francisco, of the meta tiles?
No, right. So in the case of raster, so there is a concept that to decrease the number of files, we have a kind of meta tile, which is an 8x8 group of tiles, and that's what you download.
In the case of bitmap, but what about the case of vector?
No. In the case of vector.
No. In the case of vector, in the case of bitmap, it's stored in the server also in 8x8, but you download each one in a separate way. So
okay, so wait a minute. Wait. You're telling me that when I download this, so this is crazy, by the way, what you're telling me. You're telling me that, God, this thing is spinning again. Just crazy. It's still spinning. So this is getting worse. It spins longer for longer each time. Okay, just like you would expect from some kind of memory leak.
Yeah.
Okay. But
maybe you should check your memory usage. But I mean, so is that because, so is the reason for that basically there's some overhead in the PBF files, and so you want to send over, one big file if you're going to have to download many tiles, as opposed to with images where there's very little overhead in sending a compressed image. Is that why there's a difference there?
No, I think that what they're saying is, okay, so first point is, when you request a particular region, chances are you don't hit a tile on the nose. You have to have the 9 patch effectively. Am I correct, guys?
Yes, typically a map has of the order of 10, 12 tiles.
Right, but typically a given map, right? You could hit the tile on the nose. You exactly want the tile to the tile boundaries. But normally you have a 3x3 region probably, where the tile you hit is the one in the center, but they're little pieces of some of the, well, I don't know whether it's always, obviously, if the centering is off to one side, right? In fact, you would expect that you would need in a 3x3 region of tiles, right? Mm-hmm. If you imagine that the center point, you will only need 4. You'll always need 4, right? If you have
because you could request a region, like if a zoom level 5 tile is n miles across, then if you request a giant area with zoom level 5, then it might need 20 tiles.
But at the natural level, at a natural zoom level, you would naturally need 4, wouldn't you?
I think it's more like typical maps are a bit rectangular, and they typically have 4x3 tiles, say.
Okay, partly because of projection.
It's an average of 12.
Yes, exactly. Projection needs a bit more, and tiles are 256 pixels, and our maps are 500, 600 pixels, something like that.
Okay, fine. But okay, so all right. So you think you're decently optimizing, and there's not an issue. There's not some crazy thing about how we need double the size of the CDN or something.
I mean, the estimation of tiles has worked very well for raster tiles in the past. Now, in the CDN, we may be doing a bit too much. Or 8x8, I mean, downloading chunks of 64 may be a bit too aggressive. So we have been thinking of changing that to 4x4.
So, well, 4x4 relative to 64, I don't understand. It's 16 versus 64.
Exactly. So it will.
That's a factor of 8.
4.
4. Sorry.
Yeah. So if we manage to have a map that only needs one of these 4x4, then yes, it will be 4 times faster.
Well, that's
So
very
this-
worth having. I mean,
Yeah.
is there an issue? There isn't an issue in the address space in CDN.
Exactly. That's why initially we tried to be aggressive in decreasing the number of files we put there.
No, but is there an issue with address space in CDN? I can't imagine it.
We were told not to use too much, not to have too many files.
Okay, but I think that's nonsense. I think if worst case, we have to pay for more space in CDN. Okay, this is not a problem. The global CDN of the world is big enough to accommodate our files.
We have been thinking of doing these tests of decreasing to 4x4 and seeing how much that helps in general with speed.
By the way, I can think of some interesting, if I think the CDN we're using is pretty good, but I realize that there are some crypto related CDNs or things which act like CDNs that we could be using. Spend some of our cryptocurrency on CDN space. Anyway, never mind. It's a different issue. Okay. So let's go back here. So again, I want to review. So there are 2 issues. First of all, this doesn't look very good. And second of all, it's really slow. So what else is making it slow? So it's bigger to download than the previous one.
Yes, I think the second main thing in taking time is perhaps the collision algorithm for labels. The whole process of processing sizes, breaking into letters, adapting the letters to the curves of the streets or the roads or the rivers. Do you think, Francisco? I think that's the second thing.
Well,
right, not in this particular map because we are not doing these river form letters, but in other cases, when you zoom in, yes.
well, so, okay. All right. What is it going to take to grind this? Okay. So do you have suggestions for what to do given that this is dog slow?
So I'm sure that as it happened the previous time, in a couple of cycles more, we will manage to find tricks and ways to improve this. Just so far, we haven't.
Right. But this is vector labels on top of a bitmap map, right?
Exactly. Yeah. And that looks already pretty good. But of course, in order to download the labels, we have to download the vector data because the labels are in the vector data.
No, but you don't have to download all the vector data. We could make a pure labels, labels layer. Right?
Francisco, do you have any
Definitely, without question.
I'm sure we can do it.
No, it's possible. We haven't done that, but yes,
that's what I think we should do.
Another totally different layer of data for
exactly.
only the labels. That's right.
My guess is that should be the default for right now. Am I making sense?
Yes. I understand the idea. I just don't know how much it will take us to produce that layer.
Yeah, I also think these labels are way too big. Way too big. Really ugly. Bob is commenting that many decimal places in the vector data there have to be. The world is a big place. To specify something, you've got to be down to a meter, right? Or something. Right. And that's by definition, right? From when was it? 10 million meters? When Napoleon originally defined the meter by doing the what's it around the Earth? How many meters is the circumference of the Earth?
Yes, exactly. 10 million.
Yeah.
I mean, 10 million is the quarter meridian, so the total is 40 million.
Right. Okay. So anyway, that's why you need those many bits. Do protobuffer files store numbers as text or binary? Somebody's asking here.
think it's I'm not sure. I think it's binary because basically OSM used to use XML for everything, and then they just compress it, and then they switched over to using like PDF. And my understanding is because that's a binary format, and it's like a factor. The compressed version is like a factor of 2 smaller.
Okay. But if people otherwise say it's PBF protobuffer, nothing to do with PDF portable document. There are all sorts of comments here about pinch zoom. I think it's the wrong group, but I don't know what's happened. I mean, I don't know why we don't have pinch zoom. Does anybody know? The argument for a long time was various things to do with the UI stack that we were using, but that's been solved for a couple of years now. We should bring that at the very least to the user assistance meeting, Brady.
Okay.
Okay, so let's go back to what we should be doing here. So I think the best compromise for this version is vector labels, the default being vector labels, non-vector background, which I think will still be blindingly fast, assuming you have a separate vector layer, like a label layer. Make sense?
Yes. So, but here I rely on Francisco. Do you think it's we can do in a few weeks this new layer, Francisco?
We will need to see that because yes, that's a lot of data to process and
well, it's not a lot of data in the end. It's a rather small amount of data in the end.
Right, but
in the end, but to get all the data, is to actually go through all these.
Well, then we'll do it when we do it. But then when we first release, we'll have done hopefully a decent number of the most prominent tiles, and then we'll gradually go through and do the other tiles. Right?
I see. Mm-hmm. Yep. And perhaps it's something we can release. Improve after the release. So it
well, yeah, but I mean, that's because it just comes from Joseph. Look, these labels are too big. Okay, no question about it. These labels are too big. They're ugly and too big.
Actually, but by the way, they have exactly the same size as the raster labels. Only that we always show a different zoom layer a different zoom level than the natural zoom level for this map.
Well, fine. But whatever we were doing, we optimized it. So let's do it again. Right? This is just wrong. What we're seeing here is wrong.
Right, but because if you compare these two maps, for example, they actually have this same size of the labels.
Which maps?
But no, I think the argument is that the raster maps, because we show raster maps smaller than they're supposed to.
Yes.
So if you show them at their correct, quote unquote, correct size.
Okay, I'm saying those labels are the wrong size. The labels at the quotes correct size that somebody decided were the correct size are not the correct size. And what we had done before was something that made the labels come out looking correct. Am I making sense?
We tended to show them too small.
Well, this is too big.
Yes, this may be too big. And it's unfortunate that the only country chosen is the Democratic Republic of the Congo, which is so long. But
I don't care about that. That's not the problem. The problem is these things, labels are too big. It's really a simple problem. They're a factor of 2 too big, or at least like 60% too big.
I think I also had some issues where I was doing geographic stuff, with Vector Classic, and I was like trying to display data, and the labels were sufficiently big that some of the data was sort of like hard to make out.
Right.
Are these scaled fonts? What happens when you magnify it? Are they, are they?
They're scaled.
Yeah. Okay. Mm-hmm.
Okay. It's just wrong. Let's fix it. Okay. Simple as that. That would be about the right size for those labels. You get what I'm saying?
Yep. Yeah, but probably
okay.
We can apply it.
Let's go on to the rest of the review, because I think we know we have to do things here. Again, these stupid, look at this. This is just wrong. Okay, get rid of those things. Why do we see those? I mean, this is a map. It's
I,
not.
mean, I think it's not uncommon to have those. Like I think Google Maps now has those.
I understand that, but that's because those are street maps for people trying to drive cars around, which is not what we're primarily providing. We're providing geographical maps.
So we can control the zoom level at which they appear. So perhaps it's a matter of pushing some of these zoom
I
levels.
think that'll be good, yes. At the level where you're looking primarily at cities, I don't think road labels should appear.
Well, sometimes you are interested in how to get into.
I mean, any
city.
road labels, like street names?
No, at the level where you're seeing whole cities like this,
I see. Okay.
right? I mean, at this level, it's okay. That's okay. That's probably useful at that level. But when you see when the thing is the multi-map, I don't know. I mean, again, this is something that we
it's the
should
same
probably
level,
have.
For example, in this case.
I'm sorry?
But this is the same zoom level, or not?
I don't think so. Can't imagine it. Champagne is a lot smaller than Oslo.
Exactly. It's the same size. It's about a radius of 10 miles, but of course, Oslo is bigger.
What do you mean by
Is it? I mean, I mean, another thing though is I think you would be complaining about the Champagne one if those labels were blue. So I mean, it's
Yes,
just kind of
that's
a
true, too.
quirk of the Norwegian road signage.
I was gonna say it's interesting that the Champagne one, we're getting the U.S. highways, but not the interstates. The interstates would pop a lot more.
That's true, and that's weird.
I think in vector we now show the opposites. If you change the geographics here to vector classic, for example.
I think I can hear what may not be well. I don't. We'll do it. Let's see. Geo background to vector classic. Oh God, that looks terrible. It just looks frigging terrible. I mean, those labels, I agree, it might be a little small, but this just looks terrible. Come on, guys. We got to do better than this. This is not useful.
But I always found this map particularly nice. So Urbana may be a bit too large, but the other ones are very nice.
Which other ones?
What I don't like is that
Solano.
all of them are crossed out by something. Am I the only one who thinks that? Every single word is crossed out by a line.
Well, I think that's just the nature of the fact that those things are at intersections.
Right.
I don't know, on the map on the
But
right,
I
somehow
think our-
it doesn't look so bad.
I mean, I think the Urbana one in particular has a certain because it's so big, there's a lot of stuff going on behind it. So it makes it.
Can we, if we're going to review the appearance of this, we should get Jeremy.
So by the way, I mean, just in terms of the quote unquote correct sizes and stuff like that. So I mean, if you go to openstreetmap.com and look at, what the sizes they have them much smaller, much more like the raster.
Yeah,
maps
we're
we have.
just getting it wrong, guys. It's as simple as that. We're getting it wrong. So let's fix it. Going slightly too small and having more elegant maps is better than having great big things that are huge like this. Am I making sense?
Yep.
Okay. And could you make sure that you do a review of this with Jeremy? And I'll be in it if I need to be. Fair?
Yep.
Okay, let's go on with the other things we have to look at. And I suggest the compromise, which we should look at, of using vector labels and bitmap background for now, assuming that can be done blindingly fast. Am I making sense?
Yep.
Okay, so let's see. We were.
Yes. So there are a couple of questions on names and.
Okay, and one thing that should be pinned here is this issue about now that we can do multiple layers, right? Being able to describe which layers you want, like streets versus this versus that.
Yeah, that's in the plans.
Sandra's complaining about in Africa the fact that we're only labeling 3 countries. Look, the basic problem is the labels are too big, guys. It's really the only huge problem.
Yes. So perhaps the important ones are the last two ones about names. We want to touch
well, let's just hold on.
Yeah.
Sometimes you auto-rasterize to avoid projection problems with vector primitives.
Yes. So particularly for azimuthal projections in which the topology of things change, sometimes we get those wrong. So we are auto-rasterizing some of these cases for the moment.
That's just fine.
Yeah, they look good.
Much better that than we have a great big, poking Antarctica sticking in a straight line,
right?
Because of the fact that was the way it was that was the way the vectors went.
Yeah, so this you have seen already, the fact that when you scale the maps, the labels scale with the map,
right,
rather than staying. And then, of course, if we're
talking about graphic design, we really, really, really should get.
You want me to try to get him
yes,
now?
Please.
Okay,
yes.
I will try.
I think we should call Tim too.
I'm going to have to leave, unfortunately.
Okay.
So this was about the choice of which one should be default when we make this default.
I don't know. I don't know. I mean, that's a graphic design question. I mean, there are ones that definitely shouldn't be the default.
So if you go back to the top, I think this is actually the issue I was talking about before, where I end up using vector minimal instead of vector classic because like if you try and put data over like the zoom level 6 vector classic, it's kind of like, I don't know, I think that the thicknesses are kind of weird. Like you can't even
Vector
really see
classic
what
is
Illinois
just frigging ugly. It's just frigging ugly with those great big black things in it. It's just wrong. I mean, that's much better. Vector minimal. Is vector minimal a reasonable thing in the end?
I think Tim was suggesting vector business.
That doesn't look bad either. I don't know what the difference between these two is. I mean,
vector minimal has less elements than vector business. Actually, I think they have.
Okay, but we don't want these great big things. Come on, guys. Look at this. We do not want that freeway label the same size as Chicago. Just wrong at this level. Disappointingly wrong. I mean, at that level, fine. It's got actual streets and so on. At this level, ridiculous, in my view.
Yep, I think that's easy to change.
I mean, something like Google Maps, I mean, I don't think they're that intrusive, but it's mostly just because they're, the shield is like, 3 times the thickness of the road, right? Which is to say not very big.
Yeah, right. This is where it's absurd. This thing is like mega sized.
They're completely stealing the attention. Yeah.
Yeah, it's just wrong. It's just totally wrong, guys. Sorry. Okay, I have no opinion about this. I think we're going to have to do a separate graphic design review here. Okay.
Okay.
Let's plan on that.
I did text Jeremy. I don't know if he'll.
Okay. All right. While we're at it, let's try and just knock off a couple of these other things before we wrap up here. I mean, I'm really glad that finally, after how many years is it, we managed to get this vector stuff flowing through the system. Although now we just have to figure out how to optimize it. And for goodness sake, this is just such an ugly map. Please, let's fix it. Okay?
Mm-hmm. Yeah, but it's mostly the labels, right? If the labels were smaller.
If the labels were not there, this map will be beautiful.
Mm-hmm. Right.
The map is great, except for the fact that the labels are completely wrong. Simple as that, completely wrong.
Okay.
Okay. Okay. All right. Should we just take a quick look at some of these things, like time system, for example?
We can. It's a whole new world. So, and I know you always have questions about the relativity part of these. So.
Well, I don't know why, but oh boy. So this is.
So I think the way to see this is the final freedom in data objects. So we have right now granularities, calendars, time zones. So this was the final one, or at least one missing, the time systems, to be absolutely precise.
I see. So the time system determines the coordinate. If I say it is midnight precisely right now, the question is, what does that actually mean with respect to the position of the Earth or whatever else?
Exactly. Is it with respect to atomic clocks, or with respect to the motion of the planets or the rotation of the Earth? These things were synchronized decades ago, but by now they have departed minutes. So it's important.
What do you mean? When were they synchronized?
For example, they decided to align the atomic clocks in 1956, I think, or 58, with the time that the astronomers were using.
Wow. Okay. Must
But
have been
since
early
then,
atomic clocks. Yeah.
Yeah, I think the first one was in England, 56. And these things were synchronized, and since then they have been departing, and those are the famous leap seconds.
Okay. Okay. So it's an atomic clock sitting in a certain gravitational field, and the Earth is spinning and it's glitching around. And the question is, what time is it actually?
Yeah, so TI is an atomic clock, it's an average of hundreds of atomic clocks on the geoid, and with the Earth rotating and inside the gravitational field. So it's the real clock.
Yeah, I understand. Unless the Earth changes its density or something, and those clocks are going to stay at the same rate.
Exactly. Yeah. So then,
but it also looks like there's stuff like the different policies for incorporating leap seconds and stuff like that. Just looking at the list.
Yeah. So I think after TI, the next one is UT1, which is the badly named universal time, which is the time that follows the rotation of the Earth. And if the Earth slows down or speeds up, it will be noticed there.
Okay.
So then we have UTC, which is a convention that it's following TI, but always with an integer difference with respect to TI in seconds, so that it's always less than a second from UT1.
Okay.
And so it's following UT1. So UTC is always less than a second from UT1, but an integer number of leap seconds from respect to TI. So it's as precise as TI, but represents closely what UT1 represents.
I see.
And then the other ones.
In Rogers' convention for how this works, there should be a diagram of all of this here.
Yes. I mean, I think this needs a diagram of the relations between them. Explaining what each one is in a diagram is not easy. But we certainly can have the relations.
Okay. So just for my education, barycentric. What is barycentric with respect to what? Barycentric of what?
Of the solar system. When
I think
astronomers
you should say that here. Solar system barycentric coordinate time.
Yep.
Because geocentric is with respect to the center of the Earth, presumably.
Yes, exactly.
Okay, so what do you mean by it's relative to the center of the sun?
The solar system barycenter, which is not exactly the center of the sun. It's slightly outside the sun.
Okay. Boy, Jupiter is heavy. Okay.
Yeah, right. I'm fine. And so, yeah. So this is essentially the time of the astronomers. The time if you want to follow galaxies and planets, etc. It's a time that is not affected by the gravitational field and speed of the Earth.
But how does it relate to TIE?
Well, there is a bunch of conversions. So from TIE, we go to TCG. TCG is the time at the center of the Earth, and it's the time that you would have at a point that is moving with the speed of the Earth around the sun, but without the gravitational field of the Earth.
I see.
So it has been corrected. There is no gravitational field there. So actually, it's funny because TIE is running slower than TCG, because TIE is inside the gravitational field of the Earth, but TCG is not.
Right. Okay, but it still has time dilation from the fact that it's going at a certain speed relative to.
Exactly.
So wait a minute. So which is the rest frame?
So the rest frame for TCG is this point that is at the center of the Earth. But
okay.
for TCB is the solar system.
Okay, fine. So in other words, TCG is its clock is running slower than the one for the solar system because it's moving relative to the solar system.
Right. And so then there is a transformation from TCG to TDB, and that has these oscillations due to the fact that the Earth is going at different speeds and at different points in the gravitational field of the sun. So there are oscillations there, annual oscillations, which are about 1 millisecond amplitude.
In 1 millisecond over what period of time?
A year.
Wow. Okay.
Yes. So these things accumulate. And for example, it's said that if we take into account the gravitational field of the Earth, the core of the Earth is about 2.5 years younger than the surface of the Earth.
That's a nice fact.
Mm-hmm.
I like that fact. It's not that big an effect, is it? Over 4.6 billion years.
Exactly. Yeah, but I mean, 2.5 years is quite a lot.
Right.
It's not saying it's milliseconds.
No, I mean, if you'd asked me to estimate that, I would have guessed it wasn't milliseconds, but it's an interesting number.
Mm-hmm.
I see. So the extreme case of that would be, well, in the Schwarzschild solution, the extreme case is the center of the, well, is that right? I mean, the extreme case is where the center doesn't evolve at all, presumably, where time is
right,
stopped in the center.
At the horizon, yes. So if you compare the time at the horizon with the time outside the gravitational field, it is an infinite factor.
Right. But for the Earth, it's not an infinite factor.
Right.
Interesting. Okay. Okay. Wow. Okay. All right. Well, I think I understand this. This is cool. Is this all implemented now?
Yes. So,
yes.
Yeah. So Nick has implemented all this.
Yeah, it's specifically implemented in date objects and also in Julian date. We haven't generalized it to date list or absolute time because they're frankly kind of older representations of time, and it's hard to carry around information like time system.
Yeah, I think. I mean, look, absolute time. Eventually, that will need to have it, but I mean, this is a small effect on that scale.
Right. Yeah, and
right.
It doesn't really make sense to have in time objects because we need to know where you are on an actual timeline rather than within a 24-hour cycle. So it really only makes sense in date object, and then Julian date or other things that specifically need to account for the differences in time measurement.
Right. It's only relevant for an absolute thing on the absolute time scale, not the
Exactly.
It's 7 p.m.
Yeah.
on some day.
Right. This is consulting ephemerides of what is the Earth. in the solar system.
Right. And do we get to have, I mean, yeah, okay, fine. So every spacecraft in principle needs its own time zone. I mean, time
System. Yes, once we connect to SPICE, which I think we will do for 13.1, then we will have all those two.
So then this time system thing will say Voyager 1 or something somewhere here. One of those. Is that true?
Well, I'm not sure yet. We are going to have access to the information, but I don't know how much is going to be propagated. Certainly, all the Astro staff will know about it, but I don't have the full design on.
Okay, fair enough. I mean, because in principle, we should be able to have a time system. I mean, some part of this is crazy, but I mean, we should be able to have, you know, Sirius time or something. I mean, in other words, we should be able to know. Let's see that relative. Okay, wait a minute. Let me just be unconfused here.
So perhaps I should say something here. All this has been developed for the solar system. So all this stuff is very well developed for the solar system. For example, light deflection by the sun and the planets. But there are not a general formalism to do this in full general relativity. That would be full numerical relativity. That's way too much.
Yeah, right.
So you might expect some relativity in all of these, mainly if it is within the solar system, but not so much. For example, there is no cosmology here.
Right, I understand. That's a separate story.
Exactly.
And doesn't really need to, you know, the question of, you know, did the Big Bang, what time of day did the Big Bang occur at 3 p.m. is hardly the most sensible question.
Right.
And I wonder, does one have enough data to answer? No, one doesn't have enough data to answer that, even close. No, not even. One needs vastly more precision to answer that question.
Right. We don't know enough about the beginning.
Right. Astro position.
Yes, so I'm not prepared for that. So that's going to still evolve.
Okay. Okay.
Yes.
Are we going to get astrographics as well?
Not in this version. So that will be 13.1. So this time I want to have control on time and the coordinate systems. So it's a bit like the geoposition version. And it's going to be just the astro position. So we don't need like a tangents plane to the celestial sphere or anything like that.
But so this will allow us, if we say astro position of Sirius minus astro position of, or we don't have astro distance yet.
No, not yet. So this is, I mean, one of the numbers inside astro position will be the distance or equivalent to distance. You can have parallax, for example, which is equivalent
to the Earth.
Right. So astronomers sometimes give parallax as distance information instead of information.
Right.
Instead of distance, sorry.
But so this particular thing, so there'll be the conversions between different astro coordinate systems here. But that's the main thing that will exist here.
Exactly. Yes.
Okay.
And you will be able to say things like, I'm using coordinates which are corrected of light time. So it will be like the time of observation rather than the time of emission.
Yeah, I get it. But I hope that there'll also be something where you can get raw XYZ coordinates of some kind, so that you can like plot them and you know, plot nearby stars and things.
Exactly. So see the penultimate line there. So you have the numbers, the frame, and then the coordinate system. And there's where you say, I want spherical coordinates or XYZ coordinates, or
I see,
or a projection or whatever.
Nice. It's a little different from what geoposition does, right? Because geoposition doesn't have, you don't, wait a minute, geoposition, it's only geogrid position that allows you to project to a particular projection, right?
Right. So in geoposition, we have the separation of the three main cases: geoposition, XYZ, and geogrid position. So my plan here is to have them all accumulated in this third argument, which will be more flexible and will allow you to say, and I want, rather than having XYZ, I want YCX, and I want them in kilometers. rather than in astronomical units.
I see.
Things like that.
Right. Okay. Okay. Well, it's very cool.
The zoo of possibilities is much larger in this case, and people don't use so much projections, for example, as in geo.
Right. But what's much more relevant is ecliptic coordinates, whatever those things are, all those kinds of things.
Exactly.
Okay. Well, very cool. Okay, we have some questions on the live stream. Javier is asking, when's the next Q&A for the physics project? Yes, we should have one of those. We should have one of those. We're overdue for that. Bob is asking, how would we ask that question about the Earth's core being 2 years younger than the Earth's surface? Do we have what would we compute? Is it something where we say date minus 4.6 billion years, time system arrow, geocentric time versus time system arrow TT, terrestrial time? Isn't that what it would be?
Well, it could be implemented via a change of time system. Now, as I said before, the time system that is defined for the center of the Earth is one that does not consider the gravitational field. So we actually don't yet have a time system that is the true core. We could add it, but it's not one that is used in astrophysics.
Right. Right. Fair enough. Okay. Let's see. Ethan is suggesting adding some examples once we have the information from spacecraft on fake interstellar time warps. Yes. Hans is asking about the relation of astro position to pulsars. I assume that our pulsar data will flow correctly into astro position. I mean, presumably our star positions will.
Eventually, we have to move things to return astro positions, like, I don't know, sun position, moon position, etc. So like we did with geo, returning geo positions rather than coordinates. And then we will need a way of expressing orbits, so world lines, and saying things like, from this location, where do you see this world line? And it will do the computation.
That's again a trajectory story, much as we had with flight path, and much as we had with oh gosh, what was the other thing we were just yesterday that needed trajectories? Oh gosh, there's a different thing. So flight path needs trajectories. Oh, I forget.
Mm-hmm. Yeah, this is a matter of trajectories, of integrating light rates, and you will have to say, oh, it's been deflected by the sun. We can do that.
Right. What? Wait a minute. What are you saying? Sorry.
Yes, that if we are observing something from the Earth and the light ray comes very close to the sun, this astro position will have to take into account the light deflection.
Oh gosh, gravitational lensing. Really?
Yes. I mean, the deflection by the sun is rather important. I mean, there are many effects. There are like a dozen effects, including the fact that there is aberration because the Earth moves. The object originally may be moving, and we have the catalog data from the year 2000.
You mean the proper motion of the actual object?
The proper motion, exactly, the proper motion. That's the proper name, yes.
Oh, that's a big effect. But I didn't think the gravitational lensing around the sun was a big effect unless the star was really close to the sun.
Some detectors can now see the light deflection by the fact that Jupiter is not fully spherical. So it's getting really precise.
Well, I did love the idea of having an actual telescope that, where the focal point is way out somewhere in the, I don't know, in the Oort cloud or something, the telescope made by the gravitational lensing of the sun.
Mm-hmm.
Did you see that proposal?
No.
That was kind of a year or so ago. You send a spacecraft out to the point that is the focal point for the gravitational lensing done by the sun, and then you use that to look at other things further out in the solar system.
I see.
Anyway, okay, I think those are rather subtle effects that I'm not sure can be built into our default, basic system.
Mm-hmm.
fair enough. But I mean, it seems like the most obvious things. I mean, do we have the proper motion data for the stars?
We do, and Truman has been constructing a few Wolfram repository functions that connect to catalogs out there, which are huge, and contain all that information very precisely.
Okay.
Yeah, so there are, yeah.
I mean, the proper motion of stars over historical times, is it a single vector? I mean, they're just in unaccelerated motion. Is that true?
Yes, so all observations are approximated by linear motion.
But is it a good approximation over thousands of years that the stars are in inertial motion?
I think so. They are so far that from our...
I mean, obviously, ones that are not are binaries and things like that, clearly not in inertial motion.
Yes, but those will move relatively little. I mean...
Yeah, I mean, I assume there are other cases where there are stars. Isn't the Proxima Centauri, isn't that one of the things that's in a distant ternary system that is, I mean, there must be intermediate cases from tight binaries to things which are just random stars floating around on their own.
Right. So these are the things that Jeff knows much better than I do.
Fair enough.
I mean, I will make sure that we have Jeff to discuss these things when we review this.
Okay, fine. But then, I mean, the types of things we'll get not in 13.0 are things where we can make star charts and so on.
Exactly. All the graphical stuff will come later, and we'll make use of these computations.
Right. Well, terrific. Okay, and presumably, wait a minute. Presumably, in Astro position, we'll also be able to compute the positions of planets and things. We already have those positions in astronomical data.
Right. And because, as I said, I'm planning to link to SPICE that has it will download automatically the kernels needed for this planet or this satellite or whatever. So we have very precise data.
Right. It'll download the correct epicycles.
Right, exactly.
Which is basically how it works. Okay. All right. Well, great. Anything else we should cover right now?
No, I don't think so. I think we probably need to continue a bit with the date stuff. There are other things to look at.
Okay, fine. And we need to loop back on the graphics of the vector maps and so on.
Yep.
Those things will be really great. We just need to finish polishing.
Mm-hmm.
Okay, see you all soon. Thanks to folks on the live stream for your comments.